Welcome back to the chemistry class. In previous classes, we learned about the rate of the reaction, average rate, instantaneous rate, rate law expression, factors affecting the rate of the reaction, order of the reaction. In the case of order, we discussed about the various ordered reactions. First order reaction, second order reaction, third order reaction, zero order reaction, fractional order reaction. Some students are asking about a doubt how to calculate the x and y. As I already told you, x and y are determined experimentally. That's why you can say that x and y are may or may not be equal to a and b, the stoichiometric coefficient. If x and y are same, we can simply write the order of the reaction from the balanced chemical equation. But we cannot write the order of the reaction merely looking the balanced chemical equation. So a balanced chemical equation never gives us a true picture how a reaction takes place. Because a reaction completed in several steps. Some reactions are completed in one step. Some other reactions are completed in many steps or several steps. So today we are going to discuss about these things. Elementary reaction, complex reaction and molecularity of the reaction. Elementary reaction means the reaction goes completed in a single step or one step. So a reaction takes place in one step is called elementary reaction. Once again, the reaction taking place in one step is called elementary reaction. Look at the bond. Here A gives B. It is completed in a single step. So that's why we can say that it is an elementary reaction. However, in the next case, the reaction is completed in several steps. Take example, A gives D. The reaction is completed in first A gives B, then B gives C, then C gives D. So a reaction completed in many steps, different steps, is called a complex reaction. So what is a complex reaction? In complex reaction, many elementary steps are there. A complex reaction is completing in several steps. Are you okay? So here we discuss about the complex reaction and elementary reaction. Some reactions are occur in one step. For example, O3 decomposition. O3 is decomposed into O2 plus O. It is completed in a single step. But in other examples, for example, H2O2 decomposes into H2O and oxygen in the presence of iodine and alkaline medium. The reaction is completed in two steps. We will discuss a detail later. Okay, so I think you clear about the elementary reaction and complex reaction. Elementary reaction is taking place one step. Complex reaction is completed in several steps. So in complex reaction, many elementary reactions are there. A gives B is one of the elementary reaction. B gives C, another elementary reaction. C gives D, another elementary reactions. So in complex reaction, many elementary reactions are there. All these are elementary reactions. Next we move to the unit of a rate constant. In the last class we discussed about the rate rate law and rate. So we move to the rate of the unit of the rate constant. What is the rate of the reaction? Rate is equal to the rate of reaction for a general reaction. A moles of A plus B moles of B gives products. Okay, then what is rate? Rate is equal to K into concentration of A raised to X, B raised to Y. We already discussed that A and B are may or may not be equal to X and Y, the stoichiometric coefficient. What is order? Order is equal to X plus Y. The order of the reaction is equal to X plus Y. So, what is K? K is equal to rate divided by concentration of A raised to X, B raised to Y. From this, you can understand that K is equal to A, concentration of A and B comes here. So K is equal to rate divided by concentration of molar concentration of reactants. So we have to write K is equal to rate, the unit of rate. What is the unit of rate? Mol liter inverse second inverse divided by concentration of reactants. So we take the order of the reaction is equal to N. The order of the reaction is equal to N. Then substitute mod liter inverse second inverse divided by, what is the unit of concentration? The unit of concentration is mod liter inverse whole raised to N. Okay, then is equal to mod liter inverse second inverse divided by mole raised to N liter raised to minus N. Mole raised to N liter raised to minus N. We are rearranging the equation. What we get? Mole comes to the numerator, then liter is also. So mole raised to 1 minus N. Okay. Mole comes here, mole raised to 1 minus N. Then minus N comes into the numerator. It is liter raised to N minus 1 and second inverse. You memorize the general equation for finding the order, so unit of rate constant. So let us go through the unit of K for different orders. First one, zero order reaction. In the case of zero order reaction, the order N is equal to X plus Y is the order, that we take it as N. So if N is equal to 0, what is the order? If N is equal to 1, first order reaction, N is equal to 1, so first order, the unit of K is, you substitute 1 here, mole raised to 1 minus 1. Mole raised to 1 minus 1, liter raised to 1 minus 1, second inverse. So that is the unit of K for first order is second inverse. In some question, the unit of rate constant is given in second inverse. You just understand that it is first order reaction. Next we consider the second order reaction. You just apply the values into the equation. Try to apply the values in the equation. So for second order, the unit of K is equal to, or unit of K implies, mole raised to 1 minus 2. Second order reaction N is equal to 2. Then liter raised to 2 minus 1, N minus 1, 2 minus 1, and second inverse. What is it? It is mole raised to minus 1, 1 minus 2 minus 1, liter raised to 1, and second inverse. So what is the unit of K for second order? It is mole raised to minus 1, liter raised to 1, and second inverse. Similarly, we have to write third order. I directly give the unit of K. You just apply 3 here. So mole raised to 1 minus 3, mole raised to minus 2, mole raised to n minus 1, 3 minus 1, liter raised to 3 minus 1, L square or L raised to 2, and second inverse. Can you say the unit of rate constant for zero order? You just apply 0 here. So for zero order reaction, the unit is mole mole 1 minus 0, mole itself. Then 0 minus 1, liter raised to minus 1, second inverse. So in the case of zero order, the unit of rate constant is same as the unit of rate. So very important, unit calculation of a different ordered reaction. So generally you study the equation mole raised to 1 minus n, liter raised to n minus 1. Then second raised to minus 1. Just apply the different order here. N is the order of the reaction. The order can be calculated by taking the sum of powers of concentration of reactants from the rate law equation or rate law. So x plus y is the order. N is equal to 1 first order reaction, N is equal to 2 second order reaction, N is equal to 3 third order reaction, N is equal to 0 zero order reaction. By using this general equation, you can calculate the unit of rate constant for any reaction, any order reaction, whether it is zero order, first order, second order, third order, or even fractional order. You just apply the general equation. So next we move to the molecularity of the reaction. Again, the balanced chemical equation never gives the information about the true picture about the reaction takes place. So the property molecularity helps us understanding the mechanism of a reaction. What is mechanism of a reaction? As we already learned, the mechanism is the path in which the reaction takes place, the steps in which the reaction takes place. So molecularity is the number of species. What are species? Maybe atoms, ions, molecules. So the number of species taking part in an elementary reaction which must collide to bring about a chemical reaction. ഒരു റിയാക്ഷൻ നടക്കുമ്പോൾ എത്ര മോളിക്യൂൾസ് ഒരേ സമയത്ത് കൊളൈഡ് ചെയ്യുന്നു? അങ്ങനെ കൊളൈഡ് ചെയ്യുന്ന മോളിക്യൂൾസിന്റെ നമ്പറാണ് മോളിക്കുലാരിറ്റി. The number of reacting species. Reacting species are atoms, ions, molecules, which take part in a chemical reaction or in an elementary reaction, must collide to bring about a chemical reaction. The collision should be simultaneously. So molecularity is the number of species taking part in an elementary reaction which must collide simultaneously to bring about a chemical reaction. For a chemical reaction നടക്കുമ്പോൾ എത്ര മോളിക്യൂൾസ് കൊളൈഡ് ചെയ്യുന്നുണ്ട്, അങ്ങനെ കൊളൈഡ് ചെയ്യുന്ന മോളിക്യൂൾസിന്റെ എണ്ണമാണ് മോളിക്കുലാരിറ്റി. It is a theoretical concept. As we discussed about the order is an experimental quantity. It is determined from experiments. Many methods are there. Initial rate method is there. We will discuss in later. So order is an experimental concept, but molecularity is a theoretical concept. Order may be 0, 1, 2, 3, fractional, etc. But molecularity only 1, 2, 3. Molecularity never be 0 or fractional. Order എന്ന് പറഞ്ഞാൽ ഓർഡറിന്റെ വാല്യൂസ് 0 വരാം, 1 വരാം, 2 വരാം, 3 വരാം, ഫ്രാക്ഷണൽ വരാം. പക്ഷേ മോളിക്കുലാരിറ്റി എപ്പോഴും ഹോൾ നമ്പർ ആയിരിക്കും, 1, 2, 3. So order may be 0, 1, 2, 3, even fractional, but molecularity is a whole number, 1, 2, 3. Let's consider a general reaction. A moles of A plus B moles of B. The general equation is A moles of A plus B moles of B. The stoichiometric coefficients A and B. Just take the sum of A and B. So A moles of A plus B moles of B is product. The molecularity is simply molecularity is equal to A plus B. This is general case. In generally, molecularity is equal to A plus B. So let us discuss different molecular reactions. Order may be first, second, third, fractional. Similarly, molecularity 1, molecularity 2, molecularity 3. First one is unimolecular reaction. Second is bimolecular reaction. Here we say not the first molecularity. Here we can say that unimolecular reaction, bimolecular reaction, trimolecular reactions. Are you okay? Unimolecular reaction, bimolecular reaction, then trimolecular. Tri is also known as thermomolecular reaction. Okay, so what is a unimolecular reaction? Unimolecular reaction is only one species, only one atom or one ion or one molecule take part in the chemical reaction. Such reactions are called unimolecular reaction. We will discuss the example later. Second one is bimolecular reaction. In bimolecular reaction, two species simultaneously collide to bring about a chemical reaction. Okay, the collision between two molecules gives a product. So simultaneous collision of two species gives product. Such reactions comes under bimolecular reaction. This is very important in organic chemistry. In organic chemistry, we will learn about the SN1 reaction, SN2 reaction. SN1 reaction means substitution of nucleophile by unimolecular reaction. SN2 reaction, which means substitution of nucleophile by molecular reaction. Okay, in that case, we remember this concept. Next is tri-molecular reaction or termolecular reaction. Here, three molecules, three species simultaneously collide to bring about a chemical reaction. The collision between the three molecules is simultaneous. That will bring about a chemical reaction. Okay? Are you clear? Yes. Okay, we go to the discussion of different reactions and their molecularity. Unimolecular reaction. In the case of unimolecular reaction, the number of reacting species is 1. Only one molecule is involved in the reaction. O3 decomposes gives O2 and oxygen. O3 is involved in the reaction. Another example, ammonium nitrate, NH4NO2, that gives N2 plus H2. Balancing the equation by putting 2H2. So here also only one reacting molecule involved in the reaction. In the second case, bimolecular reaction. So in bimolecular reaction, two molecules are involved in the reaction. Two reacting species simultaneous collision. Two molecules simultaneously collide to bring about a chemical reaction. 2 moles of Hi gives H2 plus I2. Here the simultaneous collision of 2 Hi, not 1 Hi, 2 Hi simultaneously collide to give a reaction H2 and the product H2 and I2. Trimolecular reaction. In trimolecular reaction, 3 molecules simultaneously collide to give a reaction. 2NO plus O2 gives 2NO2. So 2NO plus 1O2. The collision of 1 NO and O2 do not give the reaction. 2 moles of nitric oxide NO and 1 mole of oxygen will give 2 moles of NO2. So what we understand from this? Unimolecular reactions, only one molecule involved in the reaction. The collision of one molecule enough. In bimolecular reaction, 2 molecules, the simultaneous collision of 2 molecules gives the product. In trimolecular or termolecular reaction, simultaneous collision of 3 molecules gives the product. So the probability of more than 3 species, more than 3 molecules can collide to give a reaction is very small. Why? Because we know that 3 space coordinates x, y, z. So the probability of more than 3 molecules, the probability of more than 3 molecule collision is rare, is very small. Hence, the molecularity greater than 3 is not observed, not occurred. It is rare. One more time. The molecularity greater than 3 is not observed or not takes place. So, this is explained by taking another example. Here, potassium chloride plus FeSO4, 6 moles of ferrous sulfate in the presence of sulfuric acid gives potassium chloride and ferric sulfate, 3 moles of FeSO4 thrice. It is ferrous sulfate, this is ferric sulfate plus water. What is the order of reaction? The reaction apparently seemed to be 10th order, isn't it? 1 plus 6, 7. 7 plus 3, 10. So we expected the reaction is 10th order, but actually the reaction is in 2nd order. Okay, apparently the reaction seems to be 10th order. 1 plus 6 plus 3, 10. But actually the reaction takes place in a 2nd order kinetics. So this shows that the reaction takes place in many steps, several steps. So that is, this reaction is a complex reaction. What is complex reaction? The reaction completes in several or many steps are called a complex reaction. Then, which will determine or which steps controls the rate of an overall reaction? A complex reaction having many elementary reactions. So, which steps control the rate of the overall reaction? The overall reaction rate is controlled by the slowest step in a reaction. Once again, the overall rate of a reaction is controlled by the slowest step in a chemical reaction. The slowest step is known as, or it is called, rate determining step. Which step will determine the rate of the reaction? The slowest step. It is explained by taking one example. Suppose a cycle manufacturing company manufacture 1000 tires per day, 900 rims per day, approximately 500 central parts. The other parts, the main frame of the cycle in the company is approximately, you take it as 500. But the company can manufacture handle per day is 200. So how many cycle can be given into the shops? It is 200. Why? The handle manufacturing unit is slow. It is a difficult process. It takes some time. So tire is 1000 per day. Rims are 900. The other parts are making a higher number. The central part of the cycle is 500. However, the number of handle manufactured per day is 200. Thus, the number of cycles can be produced per day is 200. More than 200 cycles cannot be given into the shops. That is, the slowest manufacturing unit is the handle manufacturing unit. That unit determines the number of cycles per day given into the shops or given for selling. Similarly, in a chemical reaction, different elementary reactions occur. Some elementary reactions are very fast, some others are slow, some other is slowest. So finally, the overall rate of the reaction is determined by the slowest step. Another one, also we can discuss about the relay competition. In relay competition, 4 members are running. The person or the runner which runs slowly, the speed of that man is determine the winning chance of the team. Are you clear? Okay. So this is explained by taking another reaction. Another reaction we consider to explain the the rate determination of a complex reaction. Let's take the decomposition of hydrogen peroxide, which decomposes, gives water and oxygen. So H2O2 gives H2O plus O2. For balancing the reaction, 2H2O2 gives 2H2O plus O2. 2 into 2, 4 hydrogen, 2 into 2, 4, 2 oxygen, so the equation is balanced. The reaction occurs in the presence of iodide in alkaline medium. The reaction is occur in the alkaline medium. What is the rate of the reaction? The rate of the reaction is K into concentration of H2O2 raised to 1. Remember that here it is 2, but the order is 1. It is experimentally determined, and I minus raised to 1. The reaction is first order with respect to both H2 and I2, not a second order with respect to H2O2. So the reaction is first order with respect to both H2O2 and iodide ion, I minus. So the reaction takes place in 2 steps. Let's write the reaction in a stepwise. In the first step, H2O2 plus I minus gives H2O plus IO minus. Okay? H2O2 plus I minus gives H2O plus IO minus. This step is slow. The elementary reaction or this step is very slow. And in the second step, again 1 mole H2O2 is there. H2O2 plus IO minus gives. IO minus produced here combines with 1 mole of H2O2. That gives H2O plus O2 plus I minus. Are you clear? H2O2 plus IO minus gives H2O plus O2 plus I minus. What about the overall reaction? What about the net reaction? The net reaction, I minus cancelled. IO minus cancelled. So by adding 2H2O2 plus I minus, plus we can remove the plus sign by arrow mark. I minus is cancelled, IO minus is also cancelled. Then in the left side only 2 moles of H2O2 plus 2H2O plus O2. First step is a slow step, the second step is a fast step. As we discussed, in a complex reaction, the slowest step which determine the rate of the reaction. So in this case, which steps determine the rate of the reaction? First reaction. H2O2 plus I minus gives H2O plus IO minus. What is this IO minus? That is intermediates. The intermediates combines gives product. So both steps, in first step as well as second steps, are bimolecular elementary reaction. 2 molecules are involved. H2O2 I minus. Here H2O2 plus IO minus. In both cases, The elementary reactions are bimolecular reactions. Which step determines the rate of the reaction? First step. First step is the slowest step. That step determines the rate of the reaction. Then can you differentiate order and molecularity? Okay, you should differentiate it in your notebook. It's a very important question. Differentiate order and molecularity. So what is order? Order is the sum of the powers of concentration of reactants in a rate equation or a rate law equation. You make two columns. One column is order, another column is molecularity. Then order one difference. Then in the second column you write the molecularity difference. So what is molecularity? Order is the sum of the powers of concentration terms in a rate law expression. Molecularity is the number of reacting species which collide simultaneously to bring a chemical reaction. So here it is sum of the powers, and in the case of molecularity it is the number of species. What is the next difference? Order is an experimental concept, but molecularity is a theoretical concept. Order is determined by experimentally. Molecularity is determined by observing the elementary reaction. As we already done, 1 plus 1 bimolecular, 1 plus 1 bimolecular. So molecularity is a theoretical concept. Then order is maybe whole number, 0, even fractions. So order can be 1, 2, 3, 0 or fractional. But what is molecularity? Molecularity is only whole numbers, 1, 2, 3. More than 3 is not possible. 0 molecularity is not possible. So another difference is order is whole number 0, then fractions, etc. But molecularity is only whole number 1, 2, 3. That's another difference. Then another difference is order gives some ideas about the reaction mechanism. Only some idea. Okay, order gives some idea about the mechanism. But in the case of molecularity, it doesn't tell us anything about the mechanism. Okay, molecularity doesn't tell us any mechanism. And another important difference is order is applicable to elementary as well as complex reaction. Order can be applicable to elementary as well as complex reaction. But molecularity is applicable only for elementary reactions. Very clear? Order can be applicable to elementary reaction as well as complex reaction. But molecularity is applicable only for elementary reaction. For example, it has for complex reactions. This reaction is a complex reaction. So for a complex reaction, molecularity has no meaning. Okay, are you clear about the molecularity? So any doubt, you please note it. Then we will discuss another topic in the next section. Thank you.